this video, we will be discussing the problem find indices of two numbers in an array which add up to a given target. We are given an array of integers as an input, okay? What we have to do with it? We have to output the indices of two numbers in the array. Output of two numbers, the indices of those two numbers, which add up to a given target. So sum of two numbers should be equal to some specific target, which should be there in the input as well. Assume, we have to assume something, there is some assumptions given. Assume that each input would have exactly one solution and you cannot use the same element twice. So one such pair whose sum will equal to target, that one pair will be present exactly once only. That is, there will be no other pair or no other two elements whose sum will be equal to the target. There will be only one such pair. But the second assumption is you cannot take the same element twice. Same element means the element with the same index twice. You cannot take the first element as well as the second element with the same index. The two elements should be having the different indices. So this is also the assumption which we have to assume in the question. It is specifically mentioned. If two different elements have the same value, they can be used. Then they can be used. It means if let's say at 0th index as well as the first index, if both the indices have some same value, then I can consider a pair with 0th index and first index, even though they are having same value, because the indices are different. So we do not need to maintain uniqueness on the values. We need to maintain uniqueness on the indices. Every index, whichever two indices we should pick, both those indices should be different. They should not be same. So let's assume some example input is given. Let's take the sample input itself. That is, the sample input is having 5 number of elements. What are the elements? The elements are 2, 4, 5, 9, 8. And as you can clearly see in the sample input, there is no particular order of the values. The input values can be in any order in the array. So it is an unsorted array which is given to us. And the target value is the third input, which is target as 7 in this case. So is there any pair? Is there any two indices whose sum will be equal to 7? The answer is yes. And it is 0, 2. First 0th index, then second index. Why? Because in the question, there was one more assumption written, which was print the indices in increasing order. If two indices add up to a given target, the values at those indices, first print the smaller index, then print the greater index. That's why it is 0th index, space second index. Why? Because 0th index is having value 2, second index is having value 5, 2 plus 5 is equal to 7, it is equal to target. We are printing, or we are saying we are returning the array containing two values 0 and 2. So that's how what we have to solve in this problem. So what will happen if there is no target pair found? In this question, it is not mentioned that there will be a pair with no target found, but in a follow-up, if it is coming in an interview, you can ask it, you can clarify it with your interviewer that what should I do if there is no such pair whose sum equal to target. So for now, we are again assuming that there will be always exactly one solution possible. It means there will always be a pair. It will never be possible that there are multiple pairs. And similarly, it will never be possible that there are 0 pairs, or you can say no pairs possible. So how we can figure out, how we can find out the answers? Now coming up to the approach, let's take some array. So I'm taking almost the similar kind of array, or maybe a random array. Let me just randomize the values. Let me take 2, then let me take actually 9, then let me take 8, 4, and 5. So this array is just shuffled array because array values can be anything. This is 0th index, first index, second index, third index, fourth index. I am taking an example input. We need to figure out the target 7. Is there any pair with target 7, with sum 7? And answer is yes, 2 plus 5. But how will we figure out it? We will say the most basic approach, the brute force approach, can be a nested loop. Why? Since we have to pick two elements, one element can be picked by one loop. Another element can be picked by another loop. Two loops nested inside of one another. That is, let's say first element which I am picking is 2. Can I pick 9? Is a 2 plus 9 equal to 7? No. Can I pick 8? Is 2 plus 8 equal to 7? No. Can I pick 4? Is 2 plus 4 equal to 7? No. Can I pick 5? Is 2 plus 5 equal to 7? Yes. So return 0, 4. That is the pair indices. Let's assume the target was not 7. Let's assume the target was maybe 9. In that case, what will you do? I will say, instead of taking the first index as the 0th index, let's take some other index. Let's take first index as the first index, as the first element in the pair. Second element in the pair, can it be the first index itself? Can we take two indices having the two elements in the pair having the same index? No, we have to take a different index. Should I start the loop from the zeroth index again? Actually, no. If I have already compared nums of 0 plus nums of 1, no need to compare nums of 1 plus nums of 0. It is one and the same pair. So we can start actually with the directly second index. Is 9 plus 8 equal to 9? No. Is 9 plus 4 equal to 9? No. Is 9 plus 5 equal to 9? No. Then again, similarly, first index plus plus, that is the outer loop variable plus plus, and inner loop variable will actually start from 2 plus 1, third index. Is 8 plus 4 equal to 9? No. Is 8 plus 5 equal to 9? No. And same goes with the first index will become plus plus, second index will be the outer index plus 1. Is a 4 plus 5 equal to 9? Answer is yes. So return the pair. Return the third index, comma the fourth index. First the smaller index, then the bigger index. What will be the time? As you can clearly see, one loop, linear time, another loop, again linear time. In worst case, it will be 1 plus 2 plus 3 up till n overall total time. So it will come out to be n into n plus 1 by 2, which you can say is n square time complexity. There are two nested loops, two loops, one inside another. So that is n square quadratic time. What about space? Since we will not require any extra space, we will have constant space solution. Only two pointers, PTR1 or PTR2 are required. But can we optimize it further? Can we do better than n square time complexity? The answer is yes, we can do. What will be the optimized solution? How will I come up to the optimized solution? See, if all the elements are in random order, we need to figure out whether there is a pair which is equal to target. We cannot do it better without either taking it in certain data structure or without taking it in certain order. We have to arrange all the elements in the particular order, or we have to take some other data structure, some extra data structure in order to solve it. So the solution which we are picking will be to use some ordering of the element. And mainly there are two kinds of ordering which we can follow, either the increasing order or the decreasing order. But the question is, why will the ordering of the elements matter? Why will the ordering, if I make the elements in sorted order, that is in increasing order, why will it help me, or how can it help me? So if let's suppose I have sorted all the values, that is 2, 4, 5, 8, 9, and the target which we are figuring out is 9 only. Let's do a dry run for the 9 target itself. How we can figure out the target? If we are just having the first element at the first zeroth index, the first possible index, second index at the as the next index, you cannot optimize. You have to figure out every pair, and every pair means the outer loop will also run for all indices, inner loop will also run for all indices. But a slight change. What is that slight change? The first loop should run from left to right only. That is, the first pointer, actually, not first loop, but first pointer should run from left to right only. But what if the second pointer runs from right to left? Will it help me in any fashion? Will it help me in optimizing the time complexity if I have already sorted? So if I have already sorted, what is the time complexity to sort? It is n log n. But after sorting, am I able to do it better than n square? That is the main game. So what is the sum of this pair? It is 2 plus 9. 2 plus 9 is 11. 11 is more than 9. I have to figure out a pair with some 9. I am having a pair with some 11. The sum 11 is more than some 9. What should be the aim? The aim should be to reach the sum 9. In order to reach sum 9, I have to decrease the sum. I have to make 11 go to 9. That means I have to subtract 2 from the sum. How can I subtract the sum? How can I reduce the sum of the pair? Can I, or should I actually make 2 become 4? Or you can say 2 become 5 or 2 become 8? No, it will increase the sum. 2 becoming 4 or 5 or 8 will make it 9 plus 4, 9 plus 5, 9 plus 8. What about making the 9 value reduce? What about 2 plus 8? Yes, surely it will decrease. 2 plus 5, it will decrease. It will decrease even further than 9, but it is decreasing. The main goal is you have to decrease the sum. So what is the observation? The observation is that if one pointer is at the leftmost index in a sorted array, another pointer is at the rightmost index in the sorted array, what we can do is we can figure out the sum of the leftmost and the rightmost element. The sum is more than what we require. So how we can reduce the sum? we can reduce the sum by making the right pointer go to the previous element. That is a smaller value element because it is sorted. Sorted means previous element will be lesser value. Now again ask 2 plus 8. 2 plus 8 is 10. Again, we are having a greater sum. We need only 9. We are coming to be 10. We require a lesser sum value. So again, we will do right pointer, whatever pointer name we are giving it. Let's say we are giving it right and left. So again, we will say right pointer minus minus. That is go to the previous value, a smaller value. Now what will happen? 2 plus 5. The sum will come out to be 7. Okay. What to do with 7? 7 is smaller than 9. I want a sum 9. In order to make the sum 9, should I form a pair 5 comma 4 or 2 comma 4? Obviously, the better sum will be 5 comma 4. That is, I have to discard 2. I have to increase the sum means I have to discard the smaller value and go to a bigger value. Then only the sum will increase. So how can I discard the smaller value? I can make the left pointer go to the next index. That is, left pointer will become plus plus. So it is a simple divide and conquer strategy. Even if we do not know about divide and conquer, it is good enough, no problem. It is a simple, not exactly divide and conquer, but you can say it is a two-pointer strategy. Where what we are doing is we are figuring out the sum. If the sum is greater than what we need, decrease the sum by right minus minus. If the sum is lesser than what we need, increase the sum by making left plus plus. So in these two cases, right minus minus, right minus minus. In this case, left plus plus. So what is our sum right now? Sum right now is the array of left plus array of right, nums of left plus nums of right. It is 4 plus 5. And what is 4 plus 5? It is equal to target 9. And if it is equal to target 9, yes, the target is found. But there should be certain code, certain logic when the target is not found, when the pair with the target sum is not present. So let's assume the target which we require was not 9. Let's suppose it was 8. So in case of 8, since the sum is smaller, it is actually greater than 8, what we will do? We will try to reduce the sum. I am taking another test case where the target is 8. So I will reduce the sum. And in order to reduce the sum, what I will do? I will make the right pointer minus minus. But as soon as I make right pointer minus minus, both left and right becomes equal. So as soon as the left pointer and right pointer becomes equal, they come to the same index, we can say stop now because we cannot take the same index. Or even if, let's say, there was the right pointer going to the previous index, then also I can say that the array is empty or we have considered all the pairs. So as soon as the left and right pointer crosses each other, then we can stop. So that will be the termination condition. What will be the overall time? First, since we need sorting, in most of the programming languages, the most optimized approach to sort is using n log n, the inbuilt sorting. After doing the inbuilt sorting in increasing order, we can apply this two pointer logic, which is using a pointer from left to right, named as left pointer, another pointer from right to left, named as right pointer, and applying a strategy where if the sum will be greater or lower, we are deciding accordingly we should do left plus plus or right minus minus. So it will be taking linear time only. Why? Almost you can say half of the elements, first pointer will be traversing. Almost in average case, half of the elements n2 will be, or right pointer will be traversing. So n by 2 plus n by 2. Or even if left pointer traverses the entire array, in that case, right pointer will only traverse 0 elements. So it will always come out to be linear in nature. So overall time complexity will be n log n plus n. So overall will be n log n only because sorting is overpowering the two pointer in terms of time complexity. What about space? Since we again only require two pointers, the space complexity will again be constant, no extra space required. But we are able to optimize the time at least. So what we are going to do now is we are going to write the instruction manual. We have discussed the second milestone, that is coming up to a approach. So what is the instruction manual going to be? First step is obviously to sort the array. And in order to sort the array, we will be using the inbuilt function. So sort array using inbuilt function. And every language will have an inbuilt function to sort array in increasing order, mostly in n log n time complexity. Then second step in the instruction manual will be that we have to initialize two pointers as discussed, the left pointer and the right pointer. So initialize left integer as 0 and right integer as what? Right integer as the array dot length minus 1, n minus 1, where I'm assuming you can think easily that what is n? N is nums dot length. Now, once the two pointers are initialized, We will run the loop. Till when should we run the loop? Only till the array will have some two elements remaining, at least two elements remaining. So when I can say that? When the left will be smaller than right. Why? Because if left will be equal to right, the same index cannot be taken together. That is, we cannot have nums of I, common nums of j with I equal to j. Or also, we cannot take nums of I, common nums of j where I is greater than j. So we only have to run the loop, that is, run a while loop till what point? Till the left is smaller than right. And if it is, what we have to do? We have to take the sum as what? Take the sum as the nums of left plus nums of right. That is the value at the left pointer plus value at the right pointer. Once it is taken, there are three scenarios. It is equal to target, it is smaller than target, it is greater than target. So if sum is equal to target, is equal to target, what do we have to do? We have to return the pair in the form of indices in the array. So return an array containing left and right. That is, an array of two integers having left and right indices. Otherwise, if sum is not equal to target, then maybe sum is greater than target. If sum is greater than target, we have to decrease the sum. In order to decrease the sum, we have to make the right pointer minus minus. That is, right pointer should become 1 to the left. Make it go to the right left side actually. And if the sum is obviously not greater than target, not equal to target, then it will be less than target. And if it is less than target, what should we do? Increase the sum. How we can increase the sum? By making left pointer plus plus. That is, go towards the right side. Make the sum increase because it is array as sorted. And once this entire loop is done, in some languages, it will ask you to return something. So in order to make this code or make this instruction manual language agnostic, we are returning something. We can return null. Mostly languages supports null. So what we are doing is, in order to return something, otherwise some languages like Java will show me error that you are not returning anything after the loop. Your code is unreachable. Some kind of error will be shown. So that's why we are returning null. Although this line will never hit. Why? Because in the question, it was mentioned that exactly there will be one solution. So at some particular time, this if condition will get hit. It will never happen that it is not getting hit. So this is the entire instruction manual where we will be coding the problem in Java language, and we will also discuss about some corner test cases. First, in order to apply two-pointer logic, we will require the array to be in increasing order. So what is the inbuilt function to sort in Java? It is actually arrays dot sort, and inside the parenthesis, I will pass the array to be sorted, that is nums. Once the array is sorted, now I can apply the two pointers. That is left pointer initially 0, right pointer initially nums dot length minus 1, that is n minus 1. Once the two pointers are initialized, run a loop, run a logic, a single loop only until the point left is smaller than right. Because as soon as the left becomes equal to right or more than right, then there are no more pair remaining. We have to take the sum as what? As nums of left plus nums of right. That is the current left pointer index plus the current right pointer index value. There are three scenarios as discussed. If the sum will be equal to target, if the sum will be greater than target, if the sum will be smaller than target. So if sum is greater than target, and finally the last else will be the smaller than target. This will be smaller. Let's add else here also. Even if you do not want to add, you can still just omit it. What we have to do if the sum is found? If the sum is found, return an array containing two values having left and right. So in one line, how you can return an array having two values left and right? Return a new array, that is new keyword, integer array specifically. Square bracket means a array. But no need to specify the size 2 and then give the values as array of 0, array of 1. You can directly write in the curly brackets that I need to pass two values that are left and right. So it will automatically do what? It will automatically create an array of two size having values left index and right index and return it. So this is the short syntax. If the sum is not equal to target, then it might be greater than target. And if it is greater than target, as written in the instruction manual, we have to decrease the sum by making right pointer minus minus. And otherwise, if it is equal, not equal actually, and not greater, then only point remaining is increasing the sum by making left plus plus. So this is the entire code. If I will run this code before writing return null, let's see the first error, that what kind of error will we get if we are not returning null in the last, in particular to Java language. So it is taking some time to run. So it is saying missing return statement, or maybe you can have certain, you can say that your code is not reachable, or your code is not returning anything, although the return type is something. So for now, we are returning null because we are sure that this line will never hit. So let's see if the code is getting me the same output as a sample input's corresponding output or not. Yes. What will happen if I am saying I have not sorted the array? Let's see what is the output. Is the output same as what we require? If I have by mistake missed the sorting part. So if I have by mistake missed the sorting part, still for the sample input, actually, it is giving me the correct output. But let's try it for the test case, one more test case, which is 5, 2, 4, 5, 9, 8. And let's take the target as 7. Maybe in this case, it might give me some other output. The output which should be, that is expected output, is 0, 2. Let's see if it is giving me 0, 2 or not. It is taking some time to run, and it is actually giving 0, 2, but there might be some other test cases where it will give wrong answer. Maybe let's take some 9. What will happen for some 9? Let's see. It might give me wrong answer. It might give me correct also. Let's see, it is taking some time to run. It is taking 1, 2. Actually, it is still giving me correct. But what about 2, 9, 8, 4, 5? If the input array is unsorted and it is 2, 9, 8, 4, 5, 2, 9, 8, then let's say 4, 5. What about now? Should it give me the correct answer or not? Or will it give me the correct answer or not without sorting? That is what we are trying to see. And yes, now it is giving me a null pointer exception. So altogether, it is not running at all. It is going to some certain index which does not exist. So sorting is required in order to apply to pointer. That was the main thing. And also one more important point is that since we have sorted, we will be taking n log n time complexity. Since we are applying to pointer, we will be taking linear time, but overall dominant time will be n log n. What about space? Since we are not taking any extra space, only 2 pointers left and right, it is constant space solution. And in the question, according to the assumptions, it was specifically mentioned that we do not have to take the same index twice. That's why we are writing left smaller than right. If we are allowed to take same index twice, we can just run the loop till left less than equal to right. One follow-up before ending this video, which I want you to solve, will be, can you try to solve it in even lesser time complexity? That is, in maybe linear time complexity. Currently, we are taking n log n. If yes, will you require any extra data structure to do so? And if yes, which data structure will you use? So that will be a follow-up question which you have to explore on yourself. Till then, bye bye, take care.